this.
In this last
Hello, in this video we're going to create a road system from our OCM
I forgot to
files.
check what I have.
So in here previously I already have my OCM imported, and I cut out a little piece to work with just so it calculates somewhat faster. So I want to use a filter here, OCM filter, and I want to disable buildings and generate roads. And I don't want to have all these enabled, so I might disable a few of them like this. And now I want to take out my road tool, and in here this can be found in labs or in this project file. It's going to generate these roads for us. So we'll have these big intersection pieces, and we can go to the length units and make them smaller if you want to.
Okay, so specifically, when we open up Houdini, also, thank you to everybody who's been watching stuff on YouTube. You all rock. Getting those watch hours up and whatnot. Getting close to the 500 subscribers, although I need 1,000 subscribers and 4,000 watch hours. Holy shit, I don't know how I'm gonna get there. Sure, it will be with time and effort. I'll open recent. There we go. I'm kind of curious as to why this has this, but this one here doesn't. Yeah, here. I want these two to connect like these two do down here. So if we come over to here, we can see what's going on potentially. Why does this not connect to that? Oh, it's that. Okay. This one here is a problem, and I'm not sure how to fix it.
You can have to tweak this value depending on what roads you have. We can also change the width if you want to have bigger or smaller parts. So in this case, I'm going to keep it to default. We can also plug in our modular models. So all these pieces over here that are in the middle. So if I visualize this, so everything that is green is a modular piece.
Oh, this is actually different. Road tool. This is a road generator. Hmm. Still, I really need to fix this, and I gotta figure out why that's doing that. Why does this one work and this one not?
So we can just use modular pieces in Game Engine to fill in the straight parts. So we can have a custom piece over here. So that is just some basic settings of the road tool. Now we can use a second OCM file, and what we can do here is we can disable everything and have a other node here, and then we have these other roads which can be used for smaller roads. So let's just merge this together, and you can see that our road tool then nicely already integrates this as well. But now we want to have different size variation on these parts. So I'm going to do a grid attribute.
That might be it. Okay, what was it? Okay, so it was the filters. Because this has other data. And then if we come over to here, and then we merge these together. Does it fix it? It does not. It does not fix it. Hmm. Drop down the edit node. That's why. Interesting. So that is largely the same. So would this just be a fuse then? Nope. This is correct, and it's not fusing the way that I want it to. Huh. I wonder if this is like a max segments 10. What to? Um, mm, mm. I almost don't want to use this now. Like I almost feel like I should draw them myself, draw the roads myself. I wonder if I can. Let's try that. Let's take a look at what that would look like, right? If we did this, right? We came down here and we did a spline. Okay, let's draw a curve. Oops. And then what we're going to do is we're going to pop this into here and then hit. Yeah, okay. That just works. Oh, perfect. Sorry. We can draw our own roads now. This is too sharp. So, how are we going to do this? I think the answer ends up being that we want to, well, one, we should probably look at the road. Look at this, right? I've got to figure out why this is not working the way that I want it to. So if we delete the fuse, because we don't need the fuse, we bring this back and we go like this, and we stop skipping. Then we come down here and we take this here, and then we make sure that we've got the right one. Yeah, okay. And then we're just gonna go like this and see if that fixed it. It did not. Great. It just doesn't want to do it. I don't know why it won't do it, but it just doesn't want to do it. That can't be right. We got to figure out why this is happening. Okay, so let's take a look at this one. What's up, Monka? Chris. Okay, so specifically I want to take this one here. And we're going to go like this. And then like this. And then we're going to go like this. We're going to see what happens. It doesn't do it. Is it because these are on different... Like, are these not on the same level or something? No, they are, because they're fighting faces. I was just reading things entirely wrong for some reason. I'm debating whether or not I want to do the roads in Houdini or if I want to do the roads in Unreal. I feel like shit right now. I legitimately don't know Blender, like, at all. I don't even have Blender installed. Yeah.
Hello, and in this video,
Mm. Show world generation prototyping. That's 3 years ago. I don't know what to tell you, dude. I I just I just really don't use it. Uh, my face hurts. This was cool. This here, this is actually pretty cool.
Spawn on that curve. If you select the building again, you can increase the count. So I can go back to the curve, go to edit mode, and just draw again to turn this into a nice city. So if I go to the camera view, you can see how easily that turns into. So yeah, and if you select the buildings again, you can play with the seed to get a different look. I've added my own functionality to add some of the banners. If you look at these buildings,
Wait a moment. No, I think these guys are too realistic. Yeah, they're too realistic. This does look really cool, though. Look at that. Why does this not link to the right thing, though? Oh, wait. There it is. This is the one I was thinking. This might be really useful. Sorry, I'm just... Free Blender stylized tree generator. I'm slowly getting sidetracked. Yet again. Sorry. Sorry. Houdini I think what we might need to do you know what? Maybe it's different ones here. If I do this, we might be able to see something else. It's not it. This is just the points. Delete that. What we're gonna do is do a curve. Or sorry, a curve, right? Yeah, a curve, right? When I come into here, do this. That is not what I wanted. Did not think to do that. There we go. This is what we want. And if we come into here and we do this, we can go like this. Okay, let's take a look at this here. In relation to there. Actually, what if I just do this? Wait. Let's see. Okay, I think those are all the ones that matter. Okay, and now if we do a road generator. So that didn't work the way that I wanted it to. Hmm. Hmm. Okay, so that doesn't work. Oh, this is definitely not what I want. Okay, let's just do a regular curve, right? Okay, let's do this. What if I do this? Okay, so if I do this and pipe this into the roads, what happens? Ugh. Hmm.
Hello everyone, and welcome to this workshop about advanced road editing using Houdini and Side Effects Labs. My name is Erwin Heims, and I'm a technical artist at Ubisoft for the past 9 years, and I've worked on multiple titles, including what I've developed overview about how roads are built. And I'd like to start using Ghost Recon Wildlands as an example. Let's have a look at the roads that were generated in Ghost Recon Wildlands and how they were constructed for a project of this scale. So for Ghost Recon Wildlands, my focus was on the road building toolset, and it allowed us to produce procedurally over 600 kilometers of roads at various sizes, material styles, and also it included road proxying and terraforming for the entire world. Now over here on the right, we have the terrain as well as the finder with path over the. We have points A and B, and then while making the least amount of turns, though how many turns it makes is configurable. Then we would combine these together. We had railroads, we had large, medium, and small roads, and then we had villages. And if you combine that all together, then you get quite an extensive road network that had to be managed and maintained over a long period of time during development of the game. So the way how this was done was using a road generator tool. Now version 1 basically worked like this. Here we had our 2x2 kilometer tile, and then we could place waypoints on that tile to go from point A to B, like so. We could also place guides, if you will, for bridges and later tunnels. And then if the Pathfinder would try a path between this point and that point, then it would basically follow this connection here, creating a bridge. And then finally, we could draw an exclusion curve, which would prevent the Pathfinder from going through this area, so it would have to find a way around. So with these connections defined, we can then run them to the Pathfinder system, and this will produce these raw curves. Now these are too rough to produce final roads, so first we have to clean them. So we do a smoothing pass. We also take any intersections and flatten them. This is better for the vehicle traffic in the game. I would take any switchback turn or sharp turn in a hilly environment or on a slope, and I would widen it out, give more space for the cars to traverse. And then finally, we can create a ribbon from that and prepare a terraforming stamp. So the first thing I would do is export out this result here to a road curve network, and then also run this to a terraforming stamp, which we can then turn into terraforming textures, one for each tile of the world map. So it's easy to composite together. Speaking of compositing, here's the road system. So on the left we have the input tools, then we have the grid and the connections and how they would pathfind across the world. This would then be combined together into a larger network of roads for the entire world. We would run the terraformer through that for every tile, and that would then be run through the compositor to be stamped into the terrain. Now this toolset worked, but it had its downsides, mainly that the Pathfinder could be unpredictable, and we had the issue that roads could shift. So as a second version of this tool, I changed it around a bit. Basically, I took the pathfinding grid system and I moved it to the front. So we first had the grid for every tile in the world. Then I combined all of these editing tools into one tool, and I turned that into an editor, meaning that we save the result to a cache, and I also perform the pathfinding whenever I draw a road. So the pathfinding is now inside the editing tool. This basically meant that we had immediate results from the editing tool that we could then also immediately push into the game engine. So here's a little demonstration of this version 2 of the road builder. This is basically an editor, meaning that we have a road here in the world, but we also have it in Houdini. Because I'm using a cache, I can see it both in the game engine and in Houdini at the same time. I just have to refresh the tool. Now what I can do is I can add, remove, or update roads, and I can set their settings as well, so the type of road and its size. I can then draw waypoints and move around my waypoints until I'm happy with the path, and then save it to a cache. If I don't like something, I can also remove it. So here I can draw 2 points, and specify I want this section to be removed, and then draw a new part in between. Or I can specify this section of the road needs to be changed to a different type, and then maybe add some more roads as well. Now once this is all done, and I'm happy with the result, I can then run it through the render farm, and... Okay, so let's move on to the next topic. I would first like to talk about how we can take procedural roads and break them down into their most core components. So what do we actually need in order to build procedural roads? Now over here I have the city sample for Unreal. You can get it for free from the Epic Games Store, and it uses Houdini to construct the entire city with mod kits. That includes the streets as well. The streets themselves are made by combining mod kits together. So that means the network has to be quite clean, and it has to be predictable. Now if you want to look at this for yourself, you can find it with the city sample, so you can look for the Houdini files in there. Now over here we have a typical intersection in the city environment, and you can just imagine that there are lines running along the roads, like so. And then if they intersect, we have an intersection point. Okay, so this is where the lines are connected. We can then break it down even further by cutting the intersections into these roads as well. The intersections themselves scale depending on the road width and the angles of the intersection, so they need to provide enough space at the ends to properly create sidewalks, because otherwise they won't have the space to exist. Plus, it creates a nice space for the stop area where cars would wait. It's quite useful, actually. So here we can look at it from above, and we have again a road network here of connections and intersections. And then here on the left, we have a couple of green dots, and these are basically corners. So in the Unreal City sample, road segments are always straight, and that means that any turn is basically treated like an intersection with only 2 exits. But these don't need any stop areas like there. And then if we look at the intersections again, you can see how the intersections reserve some space on the roads around them, but then in between we have these straight segments that are basically just one section of road. It has a width, that width does not change, and it has a certain amount of lanes and a style. Okay, so since this is generated in Houdini, we can look at the files and check how they are constructed under the hood. So over here we have the proxy geometry, basically the roads, but also the highways or the overpass and the proxy buildings. Now if we have a closer look at that, and we ignore the highways for a moment, then here we have the proxy mesh for the road network. Like I said, the roads in this project are created from mod kits, and these are basically all the models combined. But if we look at it even deeper, then we can see that all the sections in between the intersections are basically just lines with a width and maybe a road type value.
I think I need my own road system. Because this one's good and all, but like, I think this is not really, this isn't going to be quite what I want.
Even further, this is basically the network
I don't think this is what I want either.
More Alembic file. The first one is the easiest. The others are more complex. All that you need is to make a course. For these examples, I loaded from Alembic file. It loads. After that, this nodes chooses intersection points and makes each curve a separate primitive. Okay. After that, you need to group these nodes. Let's change color. You need to set which.
It might be this one.
Hey guys, you are looking at part 2 of complex roads in Houdini. In this tutorial we are going to look at geometry creation and placement. We will look at some of the options we
Here we go.
So we have a convert line.
Hey guys, this is the first tutorial made by us at Dokai. It is part 1 of a series diving into road creation using Houdini. During this tutorial we will tackle the problems which arise when dealing with intersections. Without further ado, let's jump into Photoshop to go over the basics. Let's start with describing our intersection. Initially we have 3 lines, roads, coming together to form our intersection. And then I'm going to draw the geometry we are going to be creating. So basically the geometry of the intersection itself. And first divide it up because we don't really need the straight pieces at the end and we only care about the intersection itself. For the straight pieces we'll just be using a sweep. We need 2 variables to create this intersection, the length and the width. So the length, pretty easy, it's basically the length of the intersection, and the width, that's basically the width of the road. With those, we can now construct our final curve. I'm going to color that in green, and that's basically the outer edge of the intersection. Now we will be creating our test geometry. Place down a few curve nodes, and put them together with a merge. Then go into your top view, and let's draw some nice lines coming together. After this, we will be placing down a fuse. This is just to make sure we have one nice intersection point. That's what we want. Cleaning up your input.
I wonder if that's actually... Okay, let's try this. Okay, let's do this. Then we do a road generator. That worked. Okay. So I'm thinking that it is what I think it is. Here. So if we do this, and we come here and we do edit. We need to add a point for this to snap to. Point. Houdini, add a point to a curve.
Escape to come out of that, and I can see my curve there. What I might do to make this easier to see is I'm going to remove the grid. Now, what do I want to do? I want to add an extra point, and that's really simple. All I need to do is hit my return key again, or my enter key. If I hold down the control, I can then see how this lights up this segment when I roll over.
Oh, there is a point there. And it's still not working. What type of data is that, though? Is that the other data? It is the other data. That might be why. So if I do that, bring up other data, we merge.
Video, we're going to create a road, are getting some shapes. Use the lines for our instead of one is size. Now we can use a second OCM file.
Okay, so he's not using fuse. So if I skip fuse, come straight down to here, we're still not getting it. We're still missing the intersections. Houdini road generator missing intersections. Okay, wait. What if we go back here, right here, So we're looking for these 2 points. So group. Right, and then if we do by points and we do 556, 174, then do null. And find out what's missing between these two versus one that is getting this here, which is these ones here. Wait, there's one more. No, that's by itself. Okay, so it is 30. $34. That might be 33 and 34. It is, okay. So we want 33, 34, 170, and 100. There we go. And then we can skip that. There we go. Beautiful. Okay. Now we have just the select ones. We can see what the difference in the data sheet is. This shouldn't have all these. Oh, right. We need to uh, there we go. So there's nothing special about the points. We don't have the primitives. Huh. Yeah, we don't have anything special here. Okay, so we're gonna not with the points. So the points aren't what's important. If we come back here and we come into here and we say maybe it's the primitives. Okay, And then if we blast everything that's not in there and we guess from group, this is fine. And then if we zoom out, we can see that we've only got these ones available. Beautiful. Absolutely amazing. Now if we go to spreadsheet here, we can see the primitive data. There's no primitive data. There's literally, I cannot figure out why they do or do not cause an intersection. Wonder if it's a width thing? Oh, excuse me. There's the normals. There's the intersections. That's those ones. Not sure what that one is. That's this one. This is the important. Outline. That's there. Okay. Oh, you know what? I think that's it right there. Oh, you know what it is? I think I know what it is. Oh. What if we do this? What if I do this? No, that's not it. Because we're not showing abnormal stuff here. Interesting? Oh, that's why. Hmm. Now I gotta figure this one here out. I wonder if this is a size issue. What's up, Fox? It's got a good looking mirror. Dresser was hacked apart. Interesting. I think I know why this is happening. But guys, explicitly, I think I know why this here is happening. And I think if I delete this and move this, I think we can fix it. Okay, so if I move this back like this, and then I move this one back as well, might be able to force them together. Oh, that's why. That's why. So I need to split this here. So I think I need to split. To instead of that, we're gonna split it. Like having streets without side. Wait, even just. Yeah, but this is specifically I need to split here. Might be primitive split. Mm. What the? There. What's this one? Yeah, that should be the rest of it. But this is... Wait, what? That's wrong. That's not supposed to be like that. Yeah, okay, there. Can we break? No. Mm. Oh, you know what we should do? I'm gonna try. If I move this, okay, so if I do this, instead of split, what if I do an edit? What if we also dissolve this? Yeah, I think that we can just blast that actually. I don't think it's blast, it might be dissolve. Delete. No, I wish. Houdini delete point. Remove point, that's what it is. Why am I not able to remove 0.75? Oh, it's facts. Okay. I think it was 75, right? Perfect. Still. Still. I wonder if it's because it's too much of an angle. I don't think so, because like this is quite the angle. Okay, so it's not that. That is definitely a bit of a problem, but I think it's strictly because this is one piece and it needs to not be one piece. Houdini break curve at point. Use a carve. That's a little bit better, actually. Still, though, I need this to turn into a Y, and it's not for one reason or another. And it is driving me batshit crazy. I don't remember what the roundness does. Actually, this should probably be 1. We want it, we want roundness. Quite a bit of roundness. This is wrong because I don't think this is actually supposed to be 2 physical lanes. I think it's supposed to be 1. Wait, did it just work? It did work. Oh. Wait. No, it didn't. This is still the one that we're having problems with. And we're having problems here. They're all around that, like, That's not really what I wanted. uh, I could do it by hand. Maybe. Hmm. It's not what I wanted at all. Can we not? Thank you. Okay. So it's not a curve or carve or whatever. Oh, wait. No, let's go back to curve here. Cut. What if I try a polycut? I don't think it's polycut. Oh wait, 75. Okay. Wrangle. Dex. Houdini. I don't really get it. Polycat. Polycat should work. Polycat does not work. Okay. So what we want to do is take we need to split this in order to make this work. I think. I'm fairly certain. Yeah, because either that or we just draw them ourselves, because that would work too. And then we would have a little bit more control. This might be the way to go. What if we just do this? Excuse me. Would I be able to bring in another curve afterwards? Actually, wait. What if I do this?
Hello, and in this video we're gonna
Oh, wait. The amount of roundness created in there. Okay, maybe the resolution is the way to go. I fuse a bunch of these. Would this make a difference? Just gonna do that. Resolution. Just crank the resolution way up. So it wasn't that. This data still is the problem. Still not the still a problem. Okay. So what we're gonna do is we're gonna come over here and build our own from scratch now, because yeah, that just seems to be the way to go.
Which is usually one of the bigger tasks out there. Here are a few tricks. So we have a convert line that is going to create some loose primitives.
But what if no, whatever. Just boom. What was he again? Convert line. That's what it was.
Out of our geometry, then place a polypath. It's a small node, and that basically connects them again. Section point, that's what we want. Cleaning up your input is usually one of the bigger tasks out there. Here are a few tricks. So we have a convert line that is going to create some loose primitives out of our geometry.
Okay.
Then place a polypath. It's a small node, and that
Polypath.
basically connects them again, helps to create some clean curves. And after that, a resample. Depending on what kind of roads you want, you might not want to do this, but I'm going to turn on subdivision curves to create a little bit more round curves. When we look at the point numbers of our curve, we can usually see some kind of direction. Right now, they are all going basically, well, they're not all going to the curve. So this one starts low and high, and here it starts high, then it ends low, and here it also starts high and ends low. That's usually not really what you want when dealing with these kind of intersections. You want them all to go into the same direction. And there might be issues with having multiple intersections. So there's a fix for this. First, let's place a reverse node. This will be reversing the curves, and then place a merge again. Now, with those together, we are going to place down a carve. And with this carve, now, with those together, we are going to place down a carve. And with this carve, we're gonna put the first view to
I'm gonna move this over to my other screen so I can see it.
to 0, and the second view 2.5. And
Group. First U to 0, and second U to 0.5.
now we don't have, we basically doubled our primitive number. Let's also place a fuse.
Or we drop a fuse. Oh yeah, we did. Okay. There's our fuse.
But what we know now is that the inner primitives of our intersection all point towards the same direction, and that's important. Next up, we want to select the intersection. Let's place down a point wrangle. And how we are going to select our intersection is the following. First, we need to know the neighbor count of each point. So make sure your point
Fuse wrangle. Neighbor count.
range is also set to points. You can always check if this is working by making an attribute out of it. And as you can see, it works. And we can see that our point 0 has 3 neighbors, which is correct. And we don't really care if there are more rows coming in, so we're just going to say if there are more than 2 neighbors.
Curve modeling. No. Layout brush. Oh, this is this is what I was thinking of. Games. That's not too bad.
Then it's going to be an intersection, and we're going to be declaring it using an attribute.
We're not seeing that. Oh, maybe I need to do no. No, it's not. Interesting. It's not adding it to the attribute for some reason.
Now you can see that all the points have the value 0 except the intersection point, which is a value of 1.
Wait, where's the intersection point? If why is that
And let's
not
make an
working?
integer out of this.
Oh, wait, right. I'm doing an attribute wrangle. He's doing a point wrangle. I wonder if that will actually make a difference. I don't think it will. There we go.
Now I want to...
Okay, so, and then he wants to do if NC is greater than 2. If at NC is greater than 2. There's our intersection.
promote this attribute to primitive. So these entire primitives you can see over here, all will be connecting to our one intersection. So that works.
Excuse me. Yeah, this is pretty much what we've got.
That's nice. Make sure you take the maximum value because that's what we want. We want to know which primitives intersection primitive. So these entire primitives you can see over here, all will be connecting to our one intersection. So that works. That's nice. Make sure you take the maximum value because that's what we want. We want to know which primitives are part of the intersection and all the other pieces are going to be 0. Now to make sure that we only select the intersection, let's place a delete node. Delete by expression.
God damn it,
The
you
other
did
pieces. That's nice.
something.
Primitives you can see over here, all will be connecting to our one intersection. So that works.
He skipped over that. Attribute promote. Intersection ID.
That's nice. Make sure you take the maximum value because that's what we want. We want to know which primitives are part of the intersection and all the other pieces are going to be 0. Now to make sure that we only select the intersection, let's place a delete node. Delete by expression and delete all primitives which have an intersection ID of 0. Next up, we will be selecting the length of our intersection. It was the red line you saw in the beginning of the video. To do this, we first
All right, we're going to do some extra stuff here.
need to measure our primitives to see what length they are at. Place down a measure node, make sure it's set to parameter, and now you have a nice length value for each primitive. Place down a primitive wrangle, and let's create our car value.
Wait, what did he?
Value for each primitive.
Element type. Wait. Area. I think it's primitive length.
Place down a primitive wrangle, and let's create our car value.
Okay, so primitive wrangle.
Let's create a parameter for this.
Okay, let's see if that did it. Yes, it did. Okay, sweet. Look at that, see?
And now you can see our custom car value.
So he wants a F. Okay. Okay.
We want to cut off our primitives so they have the exact length which now you can see our custom car value. Let's create a parameter for this. And now you can see our custom car value. Let's create a parameter for this. And now you can see our custom car.
Wait, what?
Value. We want to cut off our primitives so they have the exact length which we want to have for our intersection.
Simple Notion. How am I? I'm doing okay. Sorry, I seem a bit distracted. I'm learning some programming, some Vex stuff, and whatnot in Houdini to make a road generator because the built-in road generator doesn't quite do exactly what I want.
There are a few problems when doing this. We can place down a carve node. And here you can immediately see that if we have only one value, it's basically between 0.
Oh, interesting. Yay! Hmm.
0 and 1, and it means or you're taking the entire curve or that part of the curve, basically 1 divided by your carve value. That's not what we want. We want to have a certain length. And this length has to be, well, probably sometimes different per primitive. So how are we going to do this? Well, at first we can delete the carve node because with the carve node it's not that easy to carve each primitive of a different length. So we're going to dive into Vex for this. Place down another primitive wrangle. I found this solution on Altforce. It's basically like a simple carve which you can use per primitive with different values. Now you can see that our carve value is basically the length which we need to put in. That's our length attribute. So let's change this one to length.
Okay, so this would be include room.h, just prim length. Interesting.
Our length attribute. So let's change this one to length.
Wait.
That's our length attribute. So let's change this one to length. As you can see, right now it's a little bit large, so let's scale this one down a little bit. As you can see, right now it's a little bit large, so let's scale this one to length.
Well, we don't have a length, right? So this would be float. Oops, if I spell float right. Right, we don't have the... Oh, okay. Wait, yeah. The length is always 0 because it doesn't matter.
As you can see, right now it's a little bit large, so
Oh, because he's going up to the attribute transfer. Carve fuse. He comes up to this attribute transfer here, right? No, he's doing an attribute create after the resample. This was not something he did initially. I feel like this guy doesn't make good tutorials. Attribute create. And this is going to be length. And this will be width. And the value of width is 2. And the value of length is 6.
So let's scale this one down.
Oh wait, but that's primitive. This is point. There we go. Ugh.
A little bit to and this one to, let's say, 0.5. That's the beginning of our intersection. We want to select the points we've just created. So those are 0.5, 6, and 4. The easy way to select these points is just take the highest point numbers for each road segment there is. Let's place down the point wrangle. First we need to point the limit. Then with the if statement we are going to select all point numbers below this point limit. And we will be removing those points. Now,
Okay, so he's doing equals
now we have our segment points. But first let's add some orientation attributes. I'm going to be doing this using a polyframe. If you don't know
I don't have any points anymore. Because you had me remove all of my points. Although I think that might be what he did too. Do I even have points anymore? Okay, I still have some points here. Okay, I do have points. Okay, we're okay. We've got points. Okay. He wants a polyframe to go above the measure.
the polyframe, it's a very handy node which is just incredibly useful when trying to create orientation attributes
We don't care about the normals.
or cleaning up your curve. And let's set the tangent name to be n.
We're doing that.
Normal.
Okay.
As you can see, my initial curves have normals right now, but the points I created as the outer second points, those don't have normals. So we need to be giving them some normals. We'll give them their
Okay, so if we take a look at the point normals here, we can see they don't have any normals. We're going to add that. I really got to get this set up.
normal of their neighbor. So they have normals.
point. Neighbor. I gotta look at that. This function lets you walk the point walk the points connected to a point, separated by a single edge, to get a list of all connected points at once using neighbors. Which neighbor to find? The neighbors are in no particular order. Use neighbor count to get the total number of neighbors. Point number, the number of the point whose neighbor you want to find, the geometry. This makes sense. I don't entirely understand this though. Anyways, moving on. The rest of this code I do understand. So like if we come back to here, this just removes a point. This is the point number. This is the primitive number. Here we get the point number. Wait. This is the number of points minus the number of primitives. If the point number is less than the point limit, then we remove it. Right, because they're all points. They're all primitives, right? And yeah. I think though that like what we just did though is doable with Carve. Like entirely with Carve. Okay, one sec. Let me see. So this just gives us the points.
I also want to know where my original intersection point was. So let's get that one. Get this off of delete original.
Attribute promote.
Place another delete node. So there's the points, delete non-selected, and there's.
This isn't what I wanted. I wanted to delete.
There's our initial intersection point. I'm not always certain if
Is not equal to. Interesting. Equals. We've got nothing. Absolutely nothing, and then you get
points
0.
are radially sorted here. So let's just add it in there. Wire the segment points into the left one, and then after that wire in the intersection point. Whenever you want to do a radial sort, there's a nice little one, and points are radius to points. to know where normal of their neighbor created as the output. They have normals. I'm not always certain if that is the point, delete non-selected, and there is our initial.
Oh, delete non-selected. That's what it is. Points. There we go.
Intersection point. I'm not always certain if the points are radially sorted here, so let's just add it in there. Wire the segment points into the left one, and then after that wire in the intersection point.
Point fop.
Whenever you want to do a radial sort, there's a nice little trick to do this in 2D. First, we need to know around which position we want to do a radial sort. That's the point position. Of our intersection point.
Wait, what? Oh, wait. There's the one that I was looking for. We can delete that. This is the one that we want here. Okay, and then if we click on this
Point. Second input
attribute P.
position, and there we go. Then you need to subtract this from the original point's position.
And then wait.
Place a vector to float from the original point.
We go from here, then we negate, right? And then
Position.
we do an add.
Place a vector to float.
Okay, vector to float.
Search for the arc tangent. Wire in. Our X and Z component. And that is going to be our sort value. So place a bind export.
Bind export. Interesting.
After this, just place a sort node.
Okay, and then we come back and then we do a sort node. Wait. The sort value. It is slightly different.
Set this to attribute.
Wait. What are we doing? Oh, sort point by attribute.
Sort value. As you can see, we still have our with attribute, and we will be using it right now. Place down a attribute promote. Set it from primitive to point. It gets a little bit abstract, but don't worry, it will all come together in the end. We're going to divide this up into 3 segments, one for each outer edge of the intersection. Place down a for loop.
Wait, what did he do?
To 3. Now it gets a little bit abstract, but don't worry, it will all come together in the end. We're going to divide this up
Sorry,
into 3
abstract.
segments, one for each outer edge of
Or
the
with
intersection.
feedback. With feedback, yeah. There we go.
Place down a for loop and make sure it runs over points. Now you can see
Wait. Pieces. There we go.
we have our first point selected, but we also want to select
I can't see which one's selected. I don't know about you guys, but I can't tell which one's being selected right now. Whatever.
the second point.
Oh wait, there it is. Feedback. Wait, feedback. No. We should be seeing the point.
Copy our first point selected and make sure it runs over points of the intersection together in the end. We're going to divide this up into 3 segments, one for each outer edge of the intersection. Place down a for loop. And make sure it reaches each outer edge of the intersection. Place down a for loop. We're going to divide this up into 3 segments, one for each outer edge of the intersection. Place down a for loop.
There we go.
And make sure it runs over points. Now you can see we have our first point selected, but we also want to select the second point. Copy our repeat again. Make sure you set it to fetch input. Place down another point fob. You could copy our repeat again. Make sure you set it to fetch input. Place down another point fob. You could also do this in wrangles, really doesn't matter that much. Whatever you like. Press create meta import node. Wire that one in. To the second input and the repeat begin into the first input. From the meta node we can get a iteration value. Type in import detail attribute.
Ugh.
Set it to second input. We're going to add one value to our current point number. Place down the model. And wire in the total amount
Oh, we're moduloing it? Interesting.
of points. Place down a compare node. Make sure this is set to integer. So we have our total number of points, which is 3. We also have this looping around over all points separately. and we're adding 1 because our total amount of point is 3, and I want those to line up nicely. Then we have an iteration value, which is per iteration, it's also going to change. And basically, this will give us a number which is 1 the moment we select the second point. And we want it to be 1 when we are not selecting the second point. So let's turn this to not equal. Place an if block. Get current point number. Place down. Remove an if block. Get current point number.
Point number.
Place down a remove point.
Interesting.
This error sometimes happens. Don't really worry about it too much. Let's make sure. But this error sometimes happens. Don't really worry about it too much. Let's make sure we have this set to integer.
Wait, what the fuck did he just do?
Worry about it too much. Let's make sure we have this set to integer.
Okay, no. PT num.
Integer. Same as this one.
Wait, fuck, he's...
We have this set to integer. Same as this one.
Input from where? Integer. There we go.
Make sure you're selecting the iteration in your import detail node. Make sure you're selecting the iteration in your import detail node. And place down a merge now. And if we set down a merge,
I have too much information here. I should have less data here.
now, you can see we're always selecting 2 points. Set this to single pass.
This makes more sense. This doesn't make sense. Oh, wait. Yeah, no. It doesn't make sense. Import. This is from his metadata is 2.
And if plays down a merge, do I want it to be? I will set it to meta angles.
I
Really
wonder
doesn't
if
matter
he
that much. Whatever you
skipped
like.
over it for
Press create meta import node. Wire that one into the second input and the
fetch metadata.
repeat begin to into the first input.
Let's fetch input. This one's supposed to be fetch metadata. My metadata, my input is 2. My metadata is, my point is to 0 here, right? Oh, my metadata is 2 here. Okay.
From the meta node, we can get a iteration value. Type in import detail attribute. Set it to second input. We're going to add one value to our current point number. Place down the modulo.
Something's maybe I got something typed wrong here.
We're always selecting 2 points. And if we place down a merge now. And if we set down a merge now.
This is wrong. I should only have 2. I have 4 points. It should be removing them. So I've definitely done something wrong here.
In your import detail node.
I don't know what this if is doing here.
Set to pretty worry. Place down a remove point. This error sometimes happens. Don't really worry about it too much. Let's make sure we have this set to integer, same as this one. Make sure we have this set to integer.
There's no error here. This is fine.
Same as this one. Make sure you're selecting the iteration in your import detail node.
This is correct. Unless it's not iterations anymore. I have too many here. This is wrong. This is why. This is wrong. This one here is right. This one's wrong. This one's wrong. Mm, there we go. I think I fixed it now.
And if we place down a merge now, and if we set down
Yeah.
a merge
these
now,
are the same.
we can see we're always selecting 2 points. So there's 2 single.
I don't see the other point though. Okay, here are my points. We're supposed to see 2 points at this merge here, but they're stacked on top of each other. His are not stacked on top of each other. So I've still done something wrong, but we're a little bit closer. Wait. That's a repeat end 1. Yeah.
Doesn't matter that much, whatever you like. Press create meta import out, wire that one into the second input, and the repeat begin into the first input.
I almost feel like it's supposed to be this. I'm trying to figure out what the point here is.
From the meta node, we can get a iteration value number, which is 3. Our total amount of point is 3, and check 1 when we are moment we select the second point. And we want it to be 1 when we are not selecting the second point. So let's turn this to not equal. Place an if block, get the current point number, place down a remove point. But this error sometimes happens. Don't really worry about it too much. Let's make sure we have this set to integer, same as this one.
There's my remove point. There's my if block. Why is my remove point not removing a point? If I click here, I do not have this. Okay, beautiful. His code is broken because he skipped over something that he did. So he skipped over something. He did something. He skipped over it. And now I don't know what he did. So that's cool. So we still got 3 here. This is calculating the modulo, right? This modulo's the Okay, so we add 1 to the total amount. So this will be 4, right? Then we modulo 4. And moduloing 4 off of the point number. This should auto loop, right? Okay, so if we 4 and then we modulo 3, this should be 1. Should never. So wait. Import details, iterations. I'm trying to figure out his mindset here. So we have int add const whatever equals at num plus 1 there. Okay, so this is now what this is going to be 4, right? And then he's doing the equals add const modulo num point. Wait, this is different. Let's do a printf. Houdini vex printf. Okay.
Welcome to Life Effect. To float bend lines with the red gradient.
Yeah, whatever. We're just going to do it by hand. Then we compare them. Okay, so if modulo 1, wait, we need to get the import details. Houdini Vex import details. Detail. Vex get detail. I think this is grabbing the detail, which is over here, but we don't have any. Any detail. We've not added a detail. That's why nothing's working. There's no iteration detail.
And so it's the second input, we set it on to select the cover points. There in the end. We're going to divide this up into 3 segments, one for each outer edge of the intersection. Place down a for loop.
So we put down the for loop, he immediately changes it.
One for each outer edge of the intersection. Place down a for
fetch. Oh, this is extract. I want. This might be the problem. This doesn't exist anymore. That's why. Okay, so he has fetch pieces and points. I have extract pieces and points. Now, I think that's not too much of a problem because this is getting just a singular point. The problem here is this is getting all 3. This is getting all 3. But we're not, this detail here doesn't give me anything. Yeah, there's no detail for this to okay, so what does VOP import detail do? Import detail attribute can fetch the attribute value from a geometry stored on disk. This doesn't, what he wants doesn't exist at this point. So I'm not sure what we're comparing to.
for loop. Point select again. It doesn't matter the input value. We're going to add one value to our current point number. Place down a modulo and wire in.
Still have the NC. I don't think I don't know if he does or not.
The total, and we're adding 1 because our total amount of point is 3, and I want those to line up nicely. Then we have an iteration value, which is per iteration. It's also going to change. And basically, this point is 3. This looping around, make sure this all points separately, and we're adding 1 because our total amount of point is 3, and I want those to line up nicely. Then we have an iteration value, which is per iteration. It's also going to change nicely. Then we have an iteration value, which is per iteration. It's also going to change. Then we have an iteration value, which is per iteration.
Yeah, I don't have I don't have the iteration. Do I have one over here? It's the feedback, right? No. Single pass 0.
It's also going to change. Now, point current in the second input much, whatever you like. Press create meta import node. You could also do this in wrangles, really doesn't matter that much, whatever you like. Press create meta import node. Where
Is fetch input. Now we have an extra point. So this is 0.0. Does this change? Yeah, it does. Okay. So there's this 0.1. This should be down to this. I think I have to download this guy's fucking tutorial to be able to do this. It's like the only way this is going to happen. What the hell did he do? Somehow he did something and he ended up with something vastly different that I do not have access to. That's fetch input, yeah. This is the width attribute being pointed over. Okay, let's go through here and see if we've got everything correct. So, point number comes up here. Oh, I see what I did wrong. I see what I did wrong. There we go. Yeah, I think that should fix it. Yeah, there we go. So it was literally point number, not number of points. Oh yeah, okay. Excuse me.
That one. We'll give this one to make sure this one is set to detail. We're in the merge as first input. That's because we're going to create. One is the inside curve, a path, and if we set down a merge now, you can see we're always selecting 2 points. So that's 2 single paths, and if we go through this, we keep selecting 2 points for each iteration, which is exactly what we want. Let's make our intersection point gray. There are 2 curves we're going to create. One is the inside curve, intersection point, 2 points for each iteration, which is exactly what we want. Let's make our intersection point gray. There are 2 curves we're going to create. One is the inside curve, and one is a outside curve. Let's start with the inside because that's the easiest one. Place down a point fob. Let's make sure this one is set to detail.
So he wants a detail Bob. There we go.
We're in the merge as first input.
Take the first input.
And let's create another fetch input node. This one will get us our intersection point.
Okay.
Which is going to be our second input.
Wait, what?
We're in the merge as first input. And let's create another fetch input node. This one will get us our intersection point, which is going to be
There we go.
Be our second input. And dive in. In here, we're first going to get the location of our intersection point. We do this the same way as last time. Make sure it's set to second input. As you can see, it doesn't matter if you're using the op input 2 or you just use. It doesn't matter if you're using op input 2 directly into file or just set the input to second input. Doesn't really matter. Let's create a point where our intersection
Add a point.
Point is.
Point value. The data. Okay.
And let's place 2 constants which have the ID of our previous points. Now we want to create a primitive.
How the fuck did he do that?
2 constants which have the ID of our previous points.
Well, we do that.
Now we want to create a primitive. To do
Okay, so these both need to be integers.
this, type in add primitive. Let's order these nicely.
Wait. Default value of what?
And place constants which have the ID of our previous points. Now we want to create a primitive. To do this, type in add primitive. Let's order these nicely and place down 3 add vertex nodes.
He's jumping all over the fucking place.
Now we want to create a primitive. To do this, type in add primitive. Let's order these nicely.
So this one, it can be 0.
And place down 3 add vertex nodes.
I wish he would stop jumping around.
And wire all those in.
Okay, so I have this, and I'm hoping that I'm gonna go to his code because he's jumping all over the place here. Wait, was this the outside or the inside?
This one will get sure this one is set to detail. We're in the merge as first input, and let's create outside curve.
Okay, we're doing outside curve. Dear God, it's so. It's not good. It's not good. Yeah, it's not good. Okay, yeah, okay, yeah, okay. I don't want to try and go through all of that without him, so we're gonna go to him.
Let's start with the inside because that's the easiest one. Place down.
Oh no, we're doing the inside.
Point for
Sorry. Not the outside, we're doing the inside. Yeah, this one is substantially easier. Okay, so this is open poly 0. This one here is 0, this one's 1. And we're adding vertex. Okay.
merge second information of our input or just our intersection point is. And let's place 2 constants which have the ID of our previous points. Now we want to create a primitive. To do this, type in add primitive. Let's order these nicely and place down 3 add vertex nodes. And wire all those in. In this one, the order isn't important. As you can see, we now have a nice primitive. That's called.
Okay, let's. That's not the primitive we want. Zero, 0. Open polygon. This should be 0. This is an integer 0 value. This is value of a 1. There we go. because changing this to 1 was not covered. You just hope that you see it while it's flashing by really quickly.
Call this inside curve.
Okay, I'm definitely naming this.
Let's place another detail fill. Make sure it's set to detail. And let's just call this outside. Wiring the same nodes. Let's dive in there.
Let's
there. This one is going to be a little bit more tricky. For this we're going to need the normals, because what we want to do is to not use the original points to create this curve, we want to offset them 90 degrees away from their normal. There's a nice little trick to get you that direction. Type in cross product.
So cross product.
Wire in the normal. And make sure the second one is set to a up vector, which is 0, 1, 0. It already automatically does that for you, which is nice. If you wire this into the normal, nothing will happen because we're still in detail mode. Let's set it to points, and now you can see.
Okay. Nothing changed. If we do points, it changes. Okay.
We have a nice 90-degree angle. Let's switch it around a few times so you can see the difference. And let's get back to our detail mode. Now, we want to select the normals of our 2 points. So let's place down 2 constants again. One for point 0. And one for point 1. Then we need to get the normals. Get attribute.
That's not what I want.
Wire in the constant. Set the attribute to normal. First input, it's a vector, and we want to access a point attribute. And
Wait.
input, wire in the constant. Set the attribute to normal. First input, it's a vector, and we want to access a point attribute. And do this also for the second point. Then wire in this cross. Then wire it into a cross product.
Wait. What?
Attribute. And do this also for the second point. Then wire in this cross.
Oh, we're keeping first on this as well. Okay.
Then wire it into a cross product. Let's copy this one. As you saw, we need to negate 1, which was, let me get that real fast, point number 0. So we need to negate our direction from point number 0. We need to get the width,
Let's type in get attribute, wire in our point ID. Zero in this case. Let's type. Type in width. Floats are 0. Let's type point ID.
Wait a sec. Let me pull up his code. We're gonna go back to here, go to the outside solver. Get attribute width is float, normal is vector. Okay, we're good. We're under the right situation here. And that's the point. Okay. Come back and go here.
0 in this case. Let's type in width. Floats, first input. It's a point attribute, so that's nice. Let's type in width. Floats, first input.
Yeah, okay.
It's a point attribute, so that's nice.
We're gonna add a multiply.
And we want to multiply this with our direction. We want to do the same thing for our other point.
Okay. There we go.
Make sure you're first inputting the vector and then the float, so the outcome will also be a vector.
Oh. Okay. Okie dokie. That makes sense. Sense is being made.
Now, finally, we need to get the position. We need to get the original position of our point.
And then this is point. It's first input.
Let's get the position.
So vector through first input to do P. Oh yeah.
Position of both points.
Okay. Control C, Control V. There we go.
And let's add these values together. And let's add a point. Let's add 2 points.
Okay, so add point.
As you can see, one is not working.
Both mine are working.
As you can see, one is not working. As you can see, one is not working, and that is because I forgot to get the new normal. And now it does.
Okay, I've got doubles, maybe? Yeah, there's a point there. I'm only, yeah.
It does work.
Yeah, no, I'm definitely missing something. I don't see my points. That's because there's a bug. Do constant name value 0. Okay, what's the error here? Error in child of op cd force vp and what the flying fuck shits is going on here? Okay, so this is 0. That's 1. Yeah, okay. There's our width multiplied. We got our cross product. What's his cross product hooked up to? Absolutely nothing. Just an up vector. Yeah, that's what ours is hooked up to. Good, good. Then we do a multiply. Yeah, This is the get attribute. The get attribute is a width with a point. Yeah. Okay. Yeah. Good, 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 good. This doesn't have an error anymore. Good, 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 good. Okay. Yeah. We don't have any points though, and it could be because we're not at home. No, we see nothing. Beautiful, beautiful, just what we like. There we go. I don't know. 0, 1. Okay, so it's this one here that's fucked up for some reason. Okay, so we got the cross product here. We multiply that by the width. Okay, we're doing that. Then we get the p-value. Yeah, first input vector 3 point, yeah. Okay. Sure, first input. This one's first input too? So it's this one. Alright, okay. First input, and then we come down here, we do an add. If I do this, which point goes away? The fucked point. Okay, yeah. The fucked point goes away when I do that. There's my fucked point. This is not getting the correct data somehow. So much fun. Okay, so here's our add point. Our sum is invalid or not correct. Cross product. It is stacking. One of these is wrong. Since we can't determine which one is wrong, we're going to do that and then rewire this up. This data goes here. Then these two go into this multiply. And then this here, the data goes into the add. And then we add this value. And that should work. We should have the thing now. Where's our value? I think it should be like here or something like that. But it's not. Oh, that's why. There we go. Beautiful. Oops.
Now, to create our final point, which contains both offsets, and it contains the initial position of our intersection. So let's get attribute.
So we do an add point. Oh no, that's just an add, right? And we do get attribute.
The position.
And we're getting the position from The first input?
of our second input.
Second input?
It's a vector. It's the first point, so we don't really need to bother about that one. Throw it in there together with our offsets. Those mix those two around. You want to use the outcome of the multiply, because it's the direction multiplied with the width, not with the added position of the initial point. Place a add point.
There you go.
That has our final point position.
Okay, so we add a point. Yeah, I guess that's kind of right.
First, remove our old points.
Maybe. I don't know
we're
how
gonna do the
much
same
I
thing
love this.
as in
Whatever.
the other node. Add primitive, add vertex,
Okay.
and let's copy this one 2 times.
Okay, so this is going to take that, and then this will be from number there, and then okay. I see what's going on here. Here we go.
And there we go. Let's place and merge just for visualization.
Yay!
This is the first core of our intersection. Next up, we will be adding UVs. If you don't really need UVs, then you're done way sooner. You can skip that part. Let's delete the merge again.
Wait.
If you really need UVs, then you're done way sooner. You can skip that part. Let's delete the merge again. And place down 2 resamples. Also, we're going to place down a control node.
Okay, so we're gonna delete this. Oops. And resample. And he said a control node.
Just place down a null. Let's call it control. Edit parameter interface.
Interesting.
Add a float. Call this resolution.
Yeah, I'm unsurprised. There we go.
Copy parameter, and let's throw it inside of this one. And let's throw it into the resample.
Yeah. Why accept? Copy parameter. Paste relevant. Oops. Is that it? Yeah. There we go.
But first, let's do a little bit of a cleanup. Lays down a polypath, a sort,
Polypath.
which sorts by vertex order, and a convert line. Right now, it's very important that we have two primitives instead of one. So when we do our resample, it does both of them separately, and we keep our middle point.
Yep.
Let's throw down it a little bit of a higher resolution.
Doesn't matter that much right
This
now.
one should be division size, not resolution.
Change that later. He's probably going to change it and not say anything.
For the other one, place down a polypath. Just copy over the polypath and the sort. You don't need to convert line for this one. That's actually important. In the resample,
Oh, interesting.
of the outside curve, you want to be setting it to subdivision curve, so you get a right, nice and round edge.
Oh. That makes sense.
Create a spare input. I always like to use spare inputs because if you want to compile our system and you have all these loose channels going everywhere, that's just really annoying. So try to get used to making lots of spare inputs so everything is compilable. And throw in the first resample. And let's set this.
Wait, what? I would love to throw in the first resample, but that's not an option. God damn it. Oh, wait, no, it is. Okay, so what we want is resample 2.
Is to a relative path. And we're not going to use the maximum length, we're going to use a maximum of segments, endpoint. putting down -1 because we have a spare input, and it will give us
Give me one sec. Hmm.
the amount of points. Now we don't need the exact amount of points, because at first you can see over here there's a double point over there. So what we need to do is to subtract 2 points, and now we have the correct segment amount.
Wait, what?
Place a fuse after the first resample, and now you can see
Okay, and then
17 points, highest number of 16.
okay, so I've got 16. Then here 17? Yeah, 17 and 17.
And the same goes for the other curve.
Beautiful. That's amazing.
In our first resample node, make sure you have this curve view attribute checked on.
Can't remember what that does.
You can see the curve view attribute going
Creates a point attribute storing the unit curve parameter value for the resample point. This is the value that the input curve would be carved at to get the corresponding output point. Note this depends on the point spacing of the input. Whoa.
from 0 to 1, and again 0 to 1. Although this is not exactly what I wanted to go from 0 to 1 and then from 1 to 0. So let's fix that. Let's place down a point VOP.
Wait, what did you say?
So let's 0 to 1 and then from 1 to 0.
Oh.
So let's fix that. Let's place down a point VOP. Don't place a fuse yet. Then place down a multiply constant. Let's multiply this.
Multiply constant.
The total amount of points by 0.5.
So we're halving them? Okay.
Keeping an integer number. Place down a compare, wiring the current point number. And set it to greater than or equal. Place down a bind node. And an if block. Out of our compare comes the condition, and our bind becomes our curve view attribute.
This is supposed to be a flip.
Our curve view attribute. Place down a complement.
What the fuck is that? Complement? Okay.
1 minus x. And finally place down a bind export. Set it to curve view again. And wire the complement into the bind export. Now we have our values going from 0 to 1 and from 1 to 0.
Right. I don't know if that's what he wanted.
Place down a few, export. Now we have our values going from 0 to 1 and from 1 to 0.
Okay, my values are very different because mine are not the same at all. So mine came through very wrong. So we're going to consult his code. Curve view. Let's make sure we've got this correctly. This is 0. Wait. Yes. Multiply const 0.5, yes. Okay, and then we do a compare, which is less than or equal to. We come over to here, and this needs to be a float. Yes. Oh, wait. That's why. There we go. Beautiful.
Place down a fuse. Let's attribute copy the curve view attribute to the other line. From point to point, place down to 1 and from 1 to 0.
Yeah.
Place down a fuse. Let's attribute copy the curve view attribute.
Attribute copy
to the other line. From points.
There we go.
The points. Attribute is curve view.
Attribute is curve view.
Don't match the position. And now we have another
wait.
view. Don't match the position. And now we have another nice curve view attribute.
Okay, now I should have my curve view. Yeah, it's beautiful.
We have the U attribute, but we don't have the V attribute yet. Place down the pointer angle. Set the curve V attribute to 1. Set the curve V attribute for 1 for the inside curve and set it to 0 for the outside curve.
Wait, what? we just set this. What was the point?
At this moment you want to merge them together again. With an add node.
Okay. I don't understand why we deleted that. Like, we did all this stuff to get the curve view in a specific order, and then we fused and then blasted it away.
We're going to replace our curves. Delete geometry, but keep the points.
Okay.
Replace our curves.
We go point, delete geometry, but keep points.
Delete geometry, but keep the points. And create a primitive by group. Close this one. Also, one thing. Close this one. Also, one thing to make sure of, if we go into our perspective viewport, if you go into display options, you can remove back faces, so you always know which side is.
I don't have it.
Go into display options, close this one. Also, one thing to make sure of, if we go.
Okay, where do I go for display options? Okay. Cool, that's useless. Seven minutes, 13 seconds. Why couldn't they just add it? Oh, it's D. Thought it was D.
Go into our perspective viewport. If you go into display options, you can remove back faces, so you always know which side is facing up, which is a very nice thing to know. For now, I'm just going to ignore it. Place.
Oh, wait. That's why. Oh, that's beautiful. Okay. Amazing.
Down in polyfill. And finally a blast. And delete primitive number 0. Now we have clean looking geometry.
That is not clean looking geometry. There's something horribly wrong. That is, though. Okay, we've got 0 through 17. That's why this needs to be reversed. I do this. I wonder why that this isn't required though. But I wonder why this. Yeah, why did that come up so weird? Where's that extra point coming from? Like this is perfect. The other one is not. And this one adds a point. There's 35 and then 36 just shows up. What? No, don't do that.
Normals are not there yet, so let's create our normals.
As always, normals. Beautiful. It's amazing.
There we go. So let's place a quick shade. Here you can see
That's not right.
here you can see the intersection you've just created.
This is not right at all. What? Okay, that's correct. What's this look like? Maybe it's a sword issue? No, so far so correct. Okay, extract points, yeah. Fetch input, yeah. Fetch metadata. Fetch metadata. Peep again. Fetch input, yeah. No, this is weird. Mine is doing something very odd and his is not. Huh. His is very different. Interesting. Okay, so his delete. Wait. Oh, okay, yeah, he doesn't have a bunch like I do. But that's fine. Okay, we come in here. Mine are a little bit all over the fucking place. That's fine. Then we fuse them. We do the convert line. We resample. I think his resample is a lot less than mine. Play path resample. Yeah, his resample is much smaller than mine. We're gonna do that. There we go. Much less. Okay. That's fine. And then we come down here to his attribute thing, which we had to take some artistic liberties. And luckily we did get it right, even though he didn't cover it. Do primitive, good. Come down to his carve here. And we're still looking good, the same. Yeah, nothing out of the ordinary. We do our fuse. We're going to make sure that our code here is the same and he didn't change something randomly on us. Beautiful, it's the same. We're going to come over to an attribute here. And point to primitive, beautiful. We can delete that because we don't need it. We do his delete. Oops. See what our delete looks like. Our delete does not function correctly. So our delete is different than his delete. For no apparent reason. Unless I typed something wrong. So this delete doesn't function correctly. Huh. His is actually changing the length, and mine is not. Here's his. Here's mine. These are two very different things. But I don't know why. Unless this has to do with the length. No? Okay. So if I do this, I get the right shape. But the second I don't do a single pass, I get the wrong shape. But when I do... Huh. His doesn't have the single pass requirement. Mine does. His works. Without. Mine does not. Mine gives me this weird shape. Also, ours are different here because mine's just points and his is not just points. How do we do verge here? Where do I lose my primitives? Oh, it's in this one. Right here. I think I did this wrong. I'm not seeing any difference. That doesn't mean that there isn't. Huh. Oh, okay, never mind. By the time we get down here, we are actually the same. So we are just points. He has 4 points. I only have 3 points, which is correct because I have less intersection. I have less of an intersection. Okay, so then what's the problem? I found a problem. He can't do 2 ways. This is better. But I wonder what would happen if, like, how would I do, let's do another line, a curve. If I wanted to draw another curve, I don't know that I can merge this, right? Yeah, that's wrong. So I need a way of adding to it. Oh, I see that fucking shape that I got. No wonder. I see it. It's right there. There, there, and there. There it is. I see the shape now. It's much smaller, but I see the shape. But then why is this? Yeah, why is this not showing all of them? Oh, merge each iteration. There we go. I found it. I found the issue.
Looking nice and clean. Now to finalize the UVs, place down a point fob. With bind, get the curve view. And also get the V attribute view.
I gotta modify this so I can add in extra widths. So every road that converges can have a different width.
And also get the V attribute photo vector. Bind export. Get it to vector. Vector, UV. Place down an attribute promote.
Wait, what?
From points to vertice.
Points to vertex.
UV. Place down a fuse. Make sure you have your quadrilateral grid turned on. Sure you have your fuse turned on.
Yeah.
Let's have a look at those UVs.
They used to be better. Interesting.
Right now they look a little bit mirrored. Also there's a little bit of distortion. Placing down a subdivide.
If I do this though, they showed up perfect. Although maybe that's not what I want. They're so bad. They're so fucking bad.
I usually fix this.
I think it's because of how small it is, though. Maybe? I don't know.
Let's do the fuse after the subdivide. Also make sure in your Subdivide that your crease weight is very high. So we're not getting those weird silvers in there. And there you go. These UVs are mainly designed to tackle a certain amount of distortion. I have multiple UV sets in another version, which will be there in a later tutorial. As you can see now, we have a very fast intersection.
Okay, wait. Let me look at his and see what the fuck I did wrong here. Okay, so we come into here. We have bind here. It is a float, yes, and it is curve view. Okay, then we have the curve V. There's our curve V, yes. We do that, and then we do a float to 3D vector, yes. Then we bind, and we bind on UV. Okay, and it stays a vector, yeah. Okay, so far we're at the exact same spot here. No, because he has UVs already. I do not have UVs after this. Points from group, yeah, this is all the same. Wonder if I copy over his, if I'll get the same. Oh, this has got to be a size thing. Let's do this. We're gonna do this. We're gonna do this. Damn it. Match size. Let's put this at the center of our world real quick. Yeah, there we go. Okay, so what we're gonna do is before we do this, right? Because we've got everything here. So what we can do is we can transform. We drop this down. Let's just edit the size of this thing real quick. Really quick. We can't. Okay, beautiful. Fucking amazing. Don't do that. Okay, so this is straight up just, I think this is an issue of size. No, it's not. Okay, this is an issue of everything being fucked beyond belief. What if I do a layout? UV layout? What if we lay out to... We maximize this. Yeah, there's no UV. There's absolutely no UV. I hate it so much. This is so bad. Something went wrong. Because I don't think that it's this. Okay, so this is his. And it still definitely has the exact same problem. And then his just works. What the fuck did I do wrong? Okay, we got them merged. We got the polyfill. Polyfill's the same. Surface offset. 2.5. Okay, interesting. I wonder if that will change anything. It does not. Like, not even a little bit. UVs are so wrong. They're so wrong, it's not even funny. Oh, wait. That's why. It's curve V, not curve U. There we go. I figured it out. And on that note, we save all of this. Save. And we call it a night because we're not done roads. We're going to finish roads hopefully tomorrow. We're pretty much done the first tutorial. We've got like 10 seconds left.
Solver, which also works in 3D. Alright guys, that was part 1 of this series. We hope you have learned something, and if you enjoyed it, make sure to follow us online for some more cool game dev stuff. For now, this was Dokai. Bye bye!
All right, we've got it.
Hey guys.
We've got it loaded up. We'll finish it tomorrow, and I will catch you all later. Thank you so much, and ta-ta for now.